So I got my little pie shirt on. You see that? Super pie? Superman. We just thought super pie was super, so we made a super shirt out of it. They got my name on it. And then those are actually 3 digits at some point in pi, at some point. When I was at Wheaton North back in either 2001 or 2002, all the teachers in the department had this shirt. And all of us had some portion of pi on the back of it at some point in the number. Right. So actually at that day on Pi Day, we actually had a math department Pi Day. In the math hallway, we had contests. Like one of the things I remember was there was an object that was like a cylinder, maybe with a pyramid on top, but it was like a whole container, and then there were marbles in there. And students had to guess how many marbles do you think are in there. I don't know if it was marbles or Skittles, or I think it was something round. Because the people that won did it through volume. They got the volume of this thing, and then they got the volume of one of the balls, and then through the comparison of that, and then what would be missing when, like with a ball, and then there's a lot of space. Actually, mathematically, the people that got the closest answer used math in order to get that answer. And they won a gift card. Supplied by the school. The school was all in on this. Then at the end of the day, we had an assembly. Do you guys know what an assembly is? Because they're illegal now, apparently. Right? Usually when someone wins state, you'd have an assembly and celebrate the teams that won state. We don't have those anymore. I don't know why. But we had a math assembly. And then, exactly what you said, one of the things was, throughout the day, students saw that we were wearing these shirts and then saw this. We didn't tell anybody anything. And then they figured out, they have a portion of pie on their back, and I bet you we're going to order the teachers. And they figured that out. So as they investigated throughout the day, all of us teachers had to be aligned in the right order for someone to win a prize for that as well. Remember, 2 of our top dog teachers, one of them, I think it was Mr. Samide, still that guy to this day, one of my favorite people I ever taught with. Top dog in our department, very respected. He was 3.14. And then the next guy was our other top dog in the department, which is also the department chair. He was the next 3 digits. Then all the rest of us had to be put in order in some way, shape, or form. I think I was like in the 4th, 5th, 6th position, if I remember correctly. Then at the end of all that, the last thing that they did, they got to put a pie on Pi Day in an elected teacher's face. And then take a guess who got elected for that pie. It was me. All right, so anyway, Mr. Popular, all right, the one that smashed remember the student that did it too, and he was in my class, and he really enjoyed himself. So anyway, so I miss those things. Sorry, Boba Fett. We used to do a lot of fun stuff back in the day, and things have changed. So just like telling that story, Mr. Sabide, if you're out there, Mr. Crowell, forgot his name a little bit there, but yes. So you have to have these memorized. Not you yet, Ethan, but off to the side. Remember the fast thing for the Pythagorean identities. Divide by r squared. Everybody, what's x over r? 3, 2, 1, go. If you don't know, what's your problem? Cosine. What's y over r? 3, 2, 1, go. Sine. And then what's r over r? I know I'm ignoring the squareds. So this is the quick way, again, that's computer, to get that one. Way off to the left. Sine squared plus cosine squared equals 1. And then remember, this may come up here. Just one simple math thing. Remember, we can reshuffle these a little bit. So that would come from subtracting sine squared. And then that's what you're going to do today, Ethan. Right off the bat, when I call on you, if you see 1 minus sine squared somewhere in your question, you can replace that with cosine squared, which is smaller, which is simplifying. We're trying to simplify big to small. This is what the whole chapter is really about, at least half of it. And then when I divide by x squared, what's y over x? When you look in that middle part, what's y over x? 3, 2, 1, go. And I swear to dog, if you got to write this, do it. Because if you still don't know cirkix or ticks, then put it up there. Because I'm asking these questions, and still some of you look at me like a deer in headlights. And that's really a problem. All right, this goes to the fact of I can't teach things when you can't remember anything from the past. That's what you guys did first semester. It's like Math 3 didn't even exist. All right, and that can't be a thing. So what's r over x? It's not x over r, it's r over x. It's cosine's brother or sister, secant squared. And then y squared. I mean, I guess you can forget, but that's why you fail. All right, it's really not about chapter 5. It's because we can't remember the stuff from before. X over y is what? It's not y over x, so it's cotangent. That's how you do it, right? And then what's y over y1? What's r over y? Not y over r, so it's cosecant. That's how you get the other three, other two. I should say all three. Then, like something I showed you yesterday, this is so wild. What's 1 equal to? Well, it's equal to when I subtract tangent squared from both sides. And I swear to dog, you're going to see this, Ethan, in an expression. If I see secant squared minus tangent squared, I can replace that with what? 1, because it's equal. That's all this is substitution. Really, today, it's like a puzzle. It really is. And that's why some of you are going to like these simplifying identities, because it's like, playing a game on your phone, and you have to like find, what is this equal, and just like move around stuff and all this other things. Okay, and actually I'm going to focus on 2 things today, and it's really 1 and 2 today are really going to take care of stuff. You might have to distribute and FOIL if it comes up. Probably going to hold off on the fractions, but you know what's really not that bad. I think we are going to have that happen, but a lot of times what happens to simplify, if you have just a listing of trig things without any squares, just try to write them all in terms of sine and cosine and see what happens. This is like the top thing that simplifies a trig expression. Top dog number 1. But then if you have trig squared, check, is a Pythagorean identity involved? And then replace it. I just talked, how would I do that, Mr. Samuelis? I literally just talked about it. If you saw something that had 1 minus sine squared in parentheses, you can change that to cosine squared, which is smaller, more simplified, no minus sign. And you can't argue with me with this. If you saw secant squared minus tangent squared in something, 1 is way simpler than that. And that, really takes that thing down. I could have done the same thing over here. 1 equals cosecant squared minus cotangent squared. So that's what we have here. Don't forget about these. Remember, the only one that doesn't matter is this middle row. If you see cosine of negative theta, you can just write it as cosine of positive theta. The other ones end up being negative on the outside, and you have to incorporate that. So that was the last thing that we had there. Okay, going back to this. And I do make this note because students are goofballs and they make up identities. This is not true. Just like this is not true. 3 squared plus 4 squared does equal 5 squared. Is 3 plus 4 equal 5? What's 3 plus 4, everybody? 7. So that's a false. So sine plus cosine doesn't equal 1. This is a false identity that often gets, submitted in your work. What I'm saying is if you see trig squared, it still might be number 1, but it might be a Pythagorean identity that you can make a replacement and make it smaller, because that's what we're doing. We're simplifying. If you have a set of parentheses with trig, maybe FOIL. It is going to happen today. And then I will have ones where we can do the opposite of the, we might have to use like common denominators back and forth. You might actually have to do the reverse of common denominators. So I'll let you write that down real quick. Ethan, you'll be lucky that you went first here because, they're more in this phase 1, number 1. And you better be ready with your identities. And I hope you're not just staring at them, because tomorrow you're going to have to fill out the identities. Remember what I told you tomorrow? You are having a quiz where these are blank. These are gone. You will have to fill out this right side. I am literally telling you what the quiz is going to be. Literally telling you what you have to do on the other side. There cannot be anything more clear about what's going to happen. I'm literally going to ask you write all 3 Pythagorean identities, so you'll have to write them. And then how you can do that is by x squared plus y squared equals r squared, and then divide by the 3 things. And as long as you know Sir Kicks or Ticks, it should be easy, and I'm going to say that because it's the second time I've covered it. Those that do not get it right still do not know Sir Kicks or Ticks, and that's on you, because Sir Kicks or Ticks was brought up in chapter 1, 2, 3, in a little bit in 4, and now we're in 5. Did I say good afternoon? Good afternoon. I said good morning when it was 11:59. Okay, All right, Ethan, you ready? Are you ready for this? Boom, 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 boom. 36, right? Nice. Okay, I'm waiting. Ethan, the first thing is the matching from yesterday, but the next section. I gave you the easy section in the homework, and I'm going to keep using that word easy. It was like tan of theta on this side, and then over on the right side, it was sine of theta over cosine of theta, and then that was it. It was just like, can you restate them? Now we got a little bit more going on. I'll lead the way here for you. Oh no, you got 38. Now, if you just want to look in the book and not have to write this all down, fine, but you're going right away. Remember what I told you? The best thing to do is to change everything in terms of sine and cosine. We already got this negative out here, so I got to incorporate that. And then this is why I like this section, because it's matching. At least I have an idea of where to go. I got to match it with one of these over here. What's tangent of x? What over what? Don't say 1 over cotan. We want to change it in sine and cosine. No, tan is not 1 over tan. No, tan is what over what. Do not say 1 over cotan. That is true, but that doesn't help me for this. So what else is it? We have no time. Is it sine over cosine or cosine over sine? Which one is it? Flip a coin. Oh no! And then this is why I can't help you here. You have got to get this memorized. That tan is sine over cosine. Only you can do that, nobody else. For yourself. Then I'm going to leave cosine. This is what I told you about fractions all year long. Oh, they're coming to pass right now, your fraction ideas. What cancels? The cosines cancel. They cross cancel. Now look to the right. Do any of these match perfectly, yes or no? Do any of these say negative sine of x? Yes. No. But which one is close to that? We can use one more rule. What negative sine of x is? A, B, C, or D, or E? C. So it's not exactly, but then this is the next thing. Negative sine of x equals sine of negative x. That's that odd, even set of identities. Whoo! I got to breathe more. Enter. Student number 2. I got to move my fat head here. Get my crooked ears. All right, here we go. All right. Nice, Jeremy. Secant squared of x minus 1. While he's answering, you can pause the video and look at my ears. Wait, this one's kind of like flat. No, wait, this one. Ooh, man, I do need ear surgery. This one's the low one. Jeremy. Oh. Okay, look at your Pythagorean identities. Do you have those in front of you? Okay, then I'll write this one. 1 plus tangent squared equals secant squared. So by a little simple reshuffle, whatever you do to one side, do to the other, what is secant squared minus 1 going to equal? This is what we got to be able to do. Not tan of x. You're missing something. Tan squared, which is not what E is. So this is actually equal to tan squared of x. Now I got to break this down so you understand this, everybody. Didn't I tell you that tan squared of x is tan of x and then squared like that, right? Because we got to get over this real quick. What is tangent equal to that Ethan eventually told you from the last question? Sine over cosine. So what letter do you think this matches now? A. The squareds go with this. Like, so if tan squared is what you have, that is equal to sine squared over cosine squared. All right, and students have a hard time getting that. That's because this is true. Going to the next simplification, tan of x is sine over cosine squared. And then guess what? You can square the numerator, square the denominator, and then write it like the trig lazy people do, the mathematicians. Okay, got it? So tan cubed is sine cubed over cosine cubed. Cotan to the 4th is cosine to the 4th over sine to the 4th. The powers carry over. Enter 8. It's so funny in this chapter. Are you here? Santino. In this chapter, we're going to have some people that do better than most chapters. And then some people just get destroyed because A, they still don't have this memorized, Sir Kicks or Ticks. And then they won't memorize this by a decision that they decided to make, because there is no reason why you shouldn't have this memorized. And then don't understand the idea of substitution and then fractions. Like this last one. I have some people that still think they don't know how to cross cancel in a fraction. And I've been trying to teach that all year long. So really it's not, again, the cat. It's our skills, right, that we need to really make sure, and our ability to memorize. All right, Santino, what is secant of x? 1 over cosine of x. I gotta have a space to put this in. And then what is cosecant of x? Because really these don't mesh very well. So I gotta try to look and see, like, I can do, this is what's great about a matching. We can eliminate, right? And I think that's how I have my matching section tomorrow. I mean, this is what you're looking at tomorrow for that part of the quiz. You should be able to get something done. You should be able to do some of these replacements. All right, and they're based off of the basic identities. And then I'm going to do this. I bet you already know. Dividing by 1 over sine is the same thing as what? Multiplying by sine. And that's how you really should write it right away. Right? And I'll give you more structure tomorrow on how to do this. Which one does this match, A through E? This is definitely E. Okay, now you get the idea of what's going to happen with this. And you have to recognize that that is simpler. All right? Next one. This one is kind of silly. Student number 13. Nice. Keeping you on the, what do we got on that? 7, 10, 11, 12, 13. Paul! Right in the back. What do we have there? Oh, I still have Felix on our sheets. Wow. I was like, who's that person behind Paul on my sheet? All right. 1 plus sine squared. Well, this one's really stupid, I think. Do you know what the letter is? Because we only have 2 left, and I'm trying to remember what I even did with this. Oh, I think I know. Look at, which letter do you think it is, B or D? Oh, did you say D? Did you say D? I couldn't hear you. Did you say B as in B or D as in Danny? B as in B-E. Get it? B. Which one do you think it is, B or D? Is that only the halfway mark? B as in boy? So which one is it actually? You know why? I want you to look at this. I think I literally just wrote this. I want you to look up here. What? Did this happen yesterday, or was it in the 5th? This happened in my 5th hour video. That's because of my stupid meetings this morning, which I got all fired up in my first one today, talking about cat and how we should have juniors in cat, and I just want to throw these papers because of, anyway. But and then I haven't had my computer plugged in. All right, here we go. Oh no! Oh, sorry, R2. Okay. Thank you. Well, no, it comes over here. Bring it over here. Do you have your earbuds out, by the way? Thank you. First day I didn't have to tell you. All right. Paul. It's right here. Actually, I didn't write it, but I wrote it over here. You see this? Do you see when this was subtracted? So then, do you see when this is subtracted? What is cosecant squared minus cotangent squared equal to? 1. So this is kind of a silly one because this is the opposite of simplifying. This is playing the matching game. This does equal that. So they're being kind of jerky here. This is the opposite of simplifying. This is playing a game. This is playing the matching game. Then I'm not going to insult anyone's intelligence by asking the last one. Of course, this is last, but I also want you to see cosine squared is 1 over secant squared. The powers carry over, and that is true. That is what happens. Okay, so the matching can be a game. I didn't like that 41 matching to D, because what we're going to be doing from here on out is simplifying and condensing, getting it smaller like some of the other stuff. For instance, let's do one at a time here. Now we're in this section. The first bell just rang. 3. Nice. Okay. So Paige, what is cosecant? Remember when I told you what majority of the times is going to happen? We change it to what? And then what is cosecant? 1 over sine. What is cosine? Are we going to change that or are we going to leave it? You leave it because you want everything in the same, let's use the word variable. And the word variable, I mean, what we want, remember when you were simplifying back in, that's wrong. Like, who cancels? What can I cancel? Like, how many y's cancel? 3, 2, 1, go. 1, and how many y's are left over where? 1 on the top. How many x's cancel? 1, and how many are left over on the bottom? 2. So we got to look at that like this, but nothing cancels so far. But then, Paige, what's tangent of theta? Because this is also where people go wrong. They just arbitrarily start changing stuff. They changed this to 1 over secant of theta. That just changed the variable. You made that z. You just made that z, and that doesn't mix with x and y. You want everything in terms of the same variable. That's why the most important method for simplifying is changing everything in terms of sine and cosine. And then you start seeing things cancel. But that's what I get. I get people that change, tangent to 1 over cotan, cosine to 1 over secant, and then maybe make this 1 over sine and nothing matches. You understand what I'm saying? Those are the ones that are going to struggle. You're just arbitrarily changing things without any thinking going on. By the way, what's the final answer, Paige? I know you're good with your fractions. 1. This cross cancels. This cross cancels. 1 times 1 times 1 over 1 times 1 times 1 is 1. Nobody can argue. That is simpler than the start. You can't argue that. That is condensed. You can argue. You'd be silly, though. And no one would listen. 14, 11, 12, 13. Felix. Oh, no. Madeline. Felix. He gone. All right. Does anyone see Felix? Tell him I said hi. All right, Maddie, you are 7. What was that? 14? 17, 18. Wait a minute. Yeah, hold on. 14. Hold on. 7, 8, 9, 10, 11, 12, 13, 14, 15, 17, 19. Something's wrong. Maybe I did keep Felix in this. So that's not you, Maddie. I thought I still had 20 in here, though. Is somebody absent today? What is going on? Carly, 1, 2, 3, 4, 5, 6, 7. Let's watch that YouTube video. 10, 11, 11. Hannah's message, 12, 13, 14. Paul, you're 14. Did I have you go at 13? All right, so then Ashley goes because she missed on 13. All right, Ashley, what's secant? And of course you can say, I don't know, I can't see it. You get it because secant. That's not stupid. What is secant? 1 over cosine. Very confident. Nicely done. And then what is tangent? If you say 1 over cotan, I'm going to throw my computer. Because again, we want to get everything in terms of the same variable. That was what tangent was. So what's cotangent? Oh, yeah, sorry. My bad, dogs. Okay, now, I guess I have space for this. So now I'm going to write this like this, just like Santino did. What is divided by sine over cosine the same as? Multiply by. Say it. I can't hear you. Everyone else is saying it. Cosine over sine. Who cancels? And then what is 1 over sine equal to, which you already did? What is 1 over sine equal to? And again, this is why doing your homework is the only way that you get these memorized, right? Cosecant of theta. You cannot argue, all right, that is not simplified. I use a double negative, which you're not supposed to, right? That is much simpler. All right, and these are the kind of little hitters, these little kind of couple steps that you're going to see tomorrow in the matching. Same old, same old. This person should not have a problem with this one. 12, 10, 11, 12. Kennedy. Nice. What's cotangent? 12, 13, 4. We're getting this row pretty good. And then you should be able to do this eventually. What's cosecant? Who cancels? We can almost think about this right now. And then what's cosine over 1 over 1 over 1? Cosine. And you cannot argue. That is definitely simpler. Okay? All right, now we got, you want to get nuts? Let's get nuts. 6. Becky, sorry. It says Rebecca. Becky and everyone else, what's wrong? Do you like how you got yelled at in the hallway again? Making sure you were. Then did you see that teacher behind, like, shaking her head at you?
Okay, I have to do the class. That's my first period.
And I got you.
Went upstairs, and I realized that my ID wasn't on. And I was like, I'm going to get yelled at for not having my ID.
I know, and then that teacher was shaking their head at you, like you got another teacher, like.
I walked all the way to the field house and I had to walk back. I'm a good person.
You are. But still got a little bit of a sneer from the teacher. All right. What is cosecant? 1 over sine. So we're actually going to break this down. In the future, Becky, I bet you're fast that you'll be able to skip this step. And then what is secant? No, notice I didn't even ask her what's cosine. I could see in this, and when you get good with this, you'll know, okay, this is what I want to do. All right? Because what's sine over 1 over sine? And then, so therefore, what is cosine over 1 over cosine? And then what's sine squared plus cosine squared? What does that equal to? 1. And you cannot argue. There's no way. That is much simpler than that start. And that's what this does. This gets you in the mode of getting these things taken care of. For the first time in forever, we have a squared. Whoa, Ethan, I love it. No earbuds? Let me see. Okay, good. Now, I know what you might want to do. When you see parentheses, you might want to distribute. But this literally is what I told you. When you see a squared, you should think in the lines of a Pythagorean identity. So what is 1 plus cotangent squared equal to? This is an awkward staring contest. No. See, you're stuck in the change into sine cosine mode, and you just gave me a robotic answer. You need to look at your identities and say, what is 1? Here we go. I got to teach you this again. X squared plus y squared equals r squared. By the way, what's cotangent? What letter over what letter? X over y, so you're going to divide by y squared. You see how I got that? What's x over y? Cotangent. What's y over y? All you need to know is what's r over y. No. Cosecant. So everybody, I just help Ethan in his memorization that this is equal to cosecant squared of theta. And Sophia's still yapping away over there with Kennedy. What's going on? Oh, okay. So you got that, right? You get it?
Actually, I didn't.
What's x over y? What's x over y? Cotangent, no time. Y over y is 1. What's r over y? Cosecant. So cosecant squared equals 1 plus cotangent squared. That's why this can be replaced as cosecant squared. Now, Ethan, what is cosecant squared? Don't say 1 plus cotangent squared. Then you're going in circles and you'll be in this question for infinity. It's a fraction that has been mentioned a few times already. Cosecant squared is 1 over sine squared. And then who cancels? A sine. What are you left with? Sine or 1 over sine? Thank you. And then you know what you can make that at the end? What's 1 over sine? Cosecant of theta. There may have been a faster way to get around that and do that, but you could almost, many of you will go from here to here because you'll understand. You should know that sine times cosecant actually equals 1 because they are reciprocals of each other. You should know that cosine times who equals 1. What should I put in there, everybody? Secant. And then same thing for tan times cotan. So many of you, when you get good with this stuff, that would be a legal maneuver. A legal maneuver, not illegal. I didn't say illegal. I just wanted to make sure you heard me. Grace came sauntering in a little late with her. Did you have your triple latte today or no? I'm sorry. It was a tea, perhaps? Okay. Was it from the Lockport store? Oh. Hey, now I know we got something going on here, but what is cotan? Cosine. See, we got a mess over here. So before we do something maybe here, we want to make this cosine over sine times sine. And then who cancels? And then when you have a set of parentheses, what have you done before in the past algebraically? Starts with an F. And these are good factors. Foil. What's 1 times 1? Now we're in this realm. Okay, because now those don't look like anything. They're not squared. So sometimes you go to the distributor FOIL thing. Sometimes you want to do math and treat the trig like a variable. Right? What time do we have? What time do we get out of here? Ah! Okay, what do we have left? Oh no. Okay. All right. So what's this FOIL? 1 times 1 is 1. All right. What's the next one? What's this?
Cosine.
What kind? Negative. No time. All right. And then what's this? Positive. What happens to those two middle terms? And then negative cosine times positive cosine is negative cosine squared. What is 1 minus cosine squared equal to? No. 1 minus cosine squared. I literally think I wrote this one. I switched them. I decided to solve for cos. So what is 1 minus cosine squared if I did something different up there? Sine squared. All right. And then just for the purposes of the video, I'll keep doing some more of these. This is sine squared. And then if you wanted to watch, nobody will. The rest of these you could as you're watching as I do this. So this is a weird one. We're going to get into this world about getting common denominators and then watch what ends up happening with this. So getting a common denominator in this one, the common denominator is this times this. That's just like what happens if I have 1/2 plus 1/3. Those are completely different. So I have to multiply this by 2 and this by 3. It's the same concept. So in this one, I have to multiply both top and bottom by sine. You can't cross cancel across a plus sign. You can only do it across a multiplication sign. I'm glad you just asked that because that is a common error. And then multiply this one by cosine. And then guess what? You have sine squared. I meant to change that to red. I hit it, but our stupid computer. Cosine squared over the common denominator written once. That's the whole idea of adding. You write them as a common denominator after. If I wish I could bring up the 1/2 and the 1/3 again when I got 3, and then the numerator becomes 1. But I was trying to get the point of how did these two turn into 1? That's how you add fractions. You carry the common denominator. All right? And then, yes, this is 1 over sine times cosine. All right, and the bell rang. They're leaving. You have your homework, and then on the other side is a bookwork assignment. Get ahead of the job here and take care of stuff. This next one is a common denominator. So this is over 1. I'm going to multiply by sine. top and bottom, and then yet again we get sine squared. Take it easy. Sine squared. Take it easy. Plus cosine squared. And then that's over a common sign. Don't be cross. Don't be canceling this. This is equal to 1. And then therefore this is 1 over sine, which of course is cosecant again. All right. And then that's definitely simpler than that. Then this last one, this is a Pythagorean identity. I'm not going to waste your time on this. 1 plus tangent squared is secant squared. Go look at the identities and you're able to make that substitution. And then you're going to be able to do this. If I have a secant, I'm talking to the computer. If you have a secant squared up on the top, since that's the reciprocal of cosine, that means cosine is on the bottom. And then since I have 1 over cosecant squared on the bottom, that means that's sine squared on the top. We could do a long convoluted, change this to 1 over cosine squared, this over 1 over sine squared, multiply, flip. But actually, I would rather you be able to do this and understand these reciprocal relationships. And then, of course, this is tan squared of theta. All right, so just in the barely passing period, I was able to finish off those examples. Tomorrow, you will have ones on the matching that this kind of stuff happens. Yes, you will.